Hello there, this is a geometry video. It is chapter 11, section 5, and today we'll be discussing areas of similar figures. You might recall that in chapter 7 we learned how to find the perimeter of similar figures, and in chapter 7 we learned that the perimeter of similar figures was proportional to the scale factor, sorry about that, of the sides of the figures. And so in a similar fashion, we have the areas of similar polygons here, or figures, and it says if two polygons are similar, then their areas are also proportional to the square of the scale factor between them. So the difference here is the square of the factor of the scale factor. So this guy right here, and my pen is already disconnected, there we go. So in the past, well, the first thing we have to do is figure out what the scale factor is. The scale factor is basically the number that you multiply to get the one figure from the previous figure. So for example, here I have two figures. I have figure A and figure B, and the dimensions of figure A are 10 by 18, and the dimensions of figure B are 5 by 9. So you can see here that the scale factor, the ratio of the sides is 5 to 9. So for perimeter, we would find the perimeter of, the blue figure, which is kind of color-coded here, would be 2 times 10 plus 2 times 18 over the perimeter of the green figure, which would be 2 times 5 plus 2 times 9. And so you would get 20 plus 36, which is going to give you 56. And then 10 plus 18, which is going to give you 28. And if you take the ratio of 56 to 28, you get 2. Alrighty? But when we do areas, for area, we have to go length times width. So you would get, for the top, you would get 10 times 18. On the bottom, you would have 5 times 9. And 10 times 18 is going to give you 180. And 5 times 9 is going to give you 45. And 180 divided by 45 is equal to 4, which is 2 squared. So the scale factor for the perimeters was 2. That also happens to be the same factor between 5 times 2 is 10 and 9 times 2 is 18. So the scale factor is 2. The perimeter is the same as the scale factor. That's what we learned in chapter 7. But today what we're concentrating on is that the areas, the ratio of the areas is going to be the square of the scale factor. So instead of it being the same as 2, it's going to be 2 squared, which is 4. So we have here another little notes for you, I guess. And we want to do here, we want to solidify in symbols anyway what we just talked about. So in this case, I'm not using rectangles, I'm using trapezoids. But again, as long as the figures are similar, so we have if trapezoid ABCD is similar to trapezoid FGHJ, then we know that the area of the green trapezoid to the area of the blue trapezoid, that ratio is the same as their scale factor squared. Alright, so we're going to do some examples with this information and see if we can further understand. So example 1 says, if triangle JKL is similar to triangle PQR, and the area of triangle JKL is 30 square inches, find the area of triangle PQR. So the first thing we have to do is find the scale factor. Okay, to find the scale factor, we have to have corresponding sides. So we can see that JK is the segment given here as 12 inches, and because they're in the same position, PQ is the side that corresponds to JK in the other figure, and in the other figure, the green figure, PQ is 15 inches. So we know that our scale factor will be the ratio of that. So I'm going to go of 12 to 15, which can be reduced because 3 goes into both of those numbers. So we'll get 4/5. So my scale factor is 4/5. And we know that the areas of the two figures will be proportional to the scale factor squared. So we're going to go 4 squared is to 5 squared, as the area of the blue figure, which is JKL, is 30. And we're trying to find the area of the green figure, which we don't know, so that's where my variable goes. And so we know that 4 squared is 16, so we're going to get 16x. And then 5 squared is 25, and 25 times 30 is going to be 750. And then we divide by 16, and we get that the area of the green figure is actually going to be 46.875 square inches. Just like that. So now we will let you do it yourself, number 1, part A and B, and then we will go to example 2. In example 2, it says the area of quadrilateral ABCD is 150 square meters. The area of quadrilateral FGHJ is 54 square meters. And it says here that the two quadrilaterals are similar. And they want us to find the scale factor of the quadrilateral. And they're telling us in which order, because it technically doesn't matter which one goes on top and which one goes on the bottom. But they are telling us that they want FGHJ, the blue, on top and the green on the bottom. So we want to find the scale factor. So we have here x is to 10. All right. So we're trying to go backwards here. We know that x is to 10. That's our scale factor. But that doesn't really give us, because we have to figure out what x is there. So we're going to actually work backwards here. And we have the areas here, which I forgot to write on the actual, oh no, it's over here. We have our areas, sorry about that. So we're going to go with our areas. And my pen is acting a little wacko. Let's not do the x over 10 first. We're going to actually start with our areas, and we're going to work backwards here. So we want to go from blue to green. So blue is FGJH, so we're going to go 54 is to 150. Now this is supposed to be our scale factor squared. So we want to go backwards, we have to square root it. But before we do that, it might be easier if we reduce this fraction. I'm pretty sure that 6 goes into both of those numbers. 54 divided by 6 is going to give us 9. And 150 divided by 6 is going to give us 25. All right? And so remember, this is the ratio of the areas, which we know is squared. So this is the same as 3 squared over 5 squared. And so now we can see that the scale factor is actually going to be 3 to 5. Okay? So now that we have our scale factor, we can go back to our x over 10. We know the scale factor is 3 to 5, and that should equal x to 10. And then we're just going to solve this by using the cross product property. So we get 5x equals 30, and divide by 5 on both sides. So x will equal 6. So they wanted us to find the scale factor, which was 3/5, and they wanted us to find the value of x, which is 6. And so now we'll let you do this do-it-yourself question, parts A and B, and then we'll go to our last example. Very short lesson today, which is nice considering that this is going to be the last section of the chapter, which means exam. So it's nice to know that it's a short one. So here we go with example 3. It says use the information on page 820. So in your textbook on page 820 off to the left-hand side of example 3, it gives us some information about the Pentagon. But it says that Orlando and Mia are making a scale model of the Pentagon. If the area of the base of their model is approximately 50 square inches, about how many times the length of each outer wall of the Pentagon is the length of the outer wall of the model? So we're trying to compare these two models. And it tells us in the information on page 820 that the Pentagon building, including its center courtyard, occupies approximately 34 acres, which translates into 1,481,000 square feet of land. So that's going to be the actual area that we have, and it's obviously in feet. So our first thing that we want to do is we have the area of, let's go in a different color here. The area of our model was given as 50 square inches, and the area of the actual pentagon is given to us as 1,481,000 feet. So the first problem that we have right here is that we'd have different units. So we want to make sure that we convert to the same units. So we're going to do that over here off to the side. And I have 50 square inches. And I know that there are 1 feet is 12 inches. And that'll cancel the inches, but we have inches squared. So we have to do this twice so that I can get square feet and cancel out the square inches. I hope that makes sense. So we're going to get 50 divided by 12 times 12. So 12 times 12 is 144. So we actually want to go 50 because our inches are going to cancel with those inches. And we're going to get 50 divided by 144 square feet. All right? And that is going to turn out to be, let's see, I did it already. You're actually going to end up with an area, instead of saying that it's going to be 50 square inches, it's actually going to be 0.3472 repeating square feet. So 50 divided by 144 is 0.347222 repeating. So now to get to figure out how many times, this is how many times the length of each outer wall, we just need to figure out the scale factor. So we're going to take 0.3472 and divide that by 1,481,000, and that's going to equal k squared, the scale factor squared. But we don't want the scale factor squared, we want just the scale factor, so we're going to square root. So our final answer is going to be k equal to the square root of this guy here, and I've already calculated that to be 0.00048, or you can round that up to 0.0005, and that is roughly basically 1/2000th. All right, so our final answer there is 1/2000th times the length. So that answers that question. So now we're going to let you do it yourself number 3 here. And I just want to remind you that since all circles have the same shape, all circles are similar. Therefore, the areas of 2 circles are also related by the square of the scale factor between them. So just because they're circles doesn't mean it's going to do anything different here. So once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.